Hello everyone, welcome to my channel. Today we are going to discuss Pure Mathematics 1 question number 10, 11 and 12 of Feb March 2020. So here is the question number 10. The gradient of a curve at point xy is given by dy over dx is 2 times x plus 3 to the power half minus x. The curve has stationary point at a comma 14 where a is a positive constant. So we need to find the value of a. The condition given here is a curve has a stationary point at a comma 14, means when x is equal to a, the dy over dx should be 0, because we know that in order to get the stationary point, the dy over dx will be 0, because in that case the gradient is going to be parallel to x-axis or horizontal. So dy by dx should be 0. So you'll simply put x is equal to a in this and we'll solve. That is 2 times a plus 3 to the power half minus a is equal to 0. So or you can write it as a plus 3 to the power half is equal to, this is a upon 2, and hence a plus 3 is equal to a square over 4, or we can cross multiply by 4 and transfer it towards the one side. We will get a square minus 4a minus 12 is equal to 0. From here we can factorize this and we will get a like 12 6, so a minus 6 and a plus 2 is equal to 0. From here you got a is equal to 6 or minus 2, but in the condition it is given that a is a positive constant, so a must be 6. So the value of a is 6. I hope it is clear. There was the condition given, we only need to proceed with the condition. Its B part is determine the nature of stationary point. So we know in order to determine the nature of a stationary point, we require d2y over dx2, and we will check whether it is greater than 0 or less than 0. If it is greater than 0, then it is going to be the minimum point, and if it is less than 0, then it is going to be the maximum point. We need to remember this. So let's find which, because dy over dx is given as 2 times x plus 3 to the power half minus x. This will give you d2y over dx2 is going to be 2 times 1 over 2 x plus 3 to the power 1 by 2 minus 1, and differentiation of x is 1. Or we can rewrite it as, we know that 1 by 2 minus 1 is minus 1 by 2, so it becomes 1 over x plus 3 power 1 by 2 and minus 1. Now let's check at a comma 14, and now since we have a value, that is 6 comma 14, so we are going to check for 6 comma 14. What is the d2y over dx square? D2y over dx square will be 1 over 6 plus 3 to the power half minus 1, and it is 1 upon 9 root of 9, that is going to be 3, 1 over 3 minus 1, and that is going to be minus 2 over 3, and we know that this is less than 0. So we can write, since d2y over dx2 is less than 0 at x is equal to 6, hence the stationary point 6 comma 14 is maximum point. I hope that is clear. We only need to remember whether d2y over dx square is greater than 0 or less than 0, and if it is greater than 0, then it is minimum, and if it is less than 0, then it is going to be maximum. So let's discuss this third part of it. We need to find the equation of curve. So we know how to find the equation of curve if we have the differentiation given, differentiation of that curve is given, and since it is 2 times x plus 3 to the power half minus x, So we can rewrite and do the integration in this way. Dy is equal to integration of 2 times x plus 3 to the power 1 by 2 minus x and dx with respect to x. So left hand side we are integrating with respect to y, so we will get y is equal to, and the integration of 2 times x plus 3 to the power half is going to be 2 is a constant, so as it is x plus 3 to the power 1 by 2 plus 1, that is 3 by 2 upon 3 by 2, and minus x integration will be x square over 2 and plus a constant c. Now we can simplify a little bit more and we can rewrite it as y, and 2 will be multiplied by 2, and it is going to be 4 over 3 times x plus 3 raised to the power 3 by 2 minus x square over 2 plus c. Now since a comma 14 was a stationary point, so you can say that a comma 14 lies on the curve. Though it is a stationary point, but it means that it should lie on the curve. So it means 6 comma 14 lies on the curve. So we can replace the value and we will get 14 is equal to 4 over 3 times 6 plus 3, that is 9 to the power 3 by 2 minus 6 square 36 over 2 plus c, and it become 18, and we can simplify it further. It is 14 is equal to 4 by 3 into 9 to the power 3 by 2, and that is 3 to the power 3, 27 minus 18 plus c. So we can cancel this, and now we can simply translate this value towards the other side. It is 4 9 is 36, 36 minus 18 is 18, so 14 minus 18 is minus 4. So c is equal to minus 4, hence we get the curve equation of that's why the equation of curve will be is going to be y is equal to 4 over 3 times x plus 3 raised to the power 3 by 2 minus x square by 2 minus 4. We can write till here also, or we can simplify it, but I'll leave it here. I hope that is clear. So here's the question number 11. Next question, A part. Solve the equation 3 tan square x minus 5 tan x minus 2 is equal to 0 in 0 and 180. We can see it is a quadratic in tan square x, so we can factorize it. It will be 3 times tan square x, and 3 to the 6, so it is minus 6 tan x plus tan x minus 2 is equal to 0, and hence we can take 3 tan x common. It is tan x minus 2 plus 1 common, and tan x minus 2 is equal to 0. So from here we can write it as tan x minus 2 3 tan x plus 1 is equal to 0, which will give you two values of tan x is equal to 2 or minus 1 over 3. So now we have tan x, so we know how to find that x, the angle, required angle, and that would be tan inverse of 2 and tan inverse of this. So from here x will be either tan inverse of 2 or tan inverse of minus 1 over 3. So tan inverse of 2 is 63.434 and so on degree. So we will write till one decimal place, that is 63.4 degree. And the next angle will be 180 plus 63.4, which is not acceptable of course. and in this case it is going to be tan inverse minus 1 by 3, it is minus 18.434, and tan inverse minus 1 by 3 is minus 18.434, which is of course not in this range. So we will find the next angle, and the next angle is 180 plus theta, and here theta is minus 18.434. So we can rewrite it as 180 plus, so 180 minus 18.434, which is going to be 161.566. So one decimal place it is 6 degree. So they are the two solutions of this. I hope that is clear. So let's discuss the second part. So second part is find the set of values of k for which the equation this has no solutions. So we know from the quadratic equation, in order to get no solutions, discriminant d should be less than 0, and here the discriminant is b square minus 4ac, that is minus 5 square minus 4 times a is 3 and c is k. This should be less than 0, or you can say 25 minus 12k is less than 0, or from here we can say that 12k should be greater than 25. I translated this minus 12k that side, or we can say that k should be greater than 25 over 12. 25 over 12, or we can write in the decimal also, but that will not be terminating, so we leave your answer here. So in order to not get any solutions, k should be greater than 25 by 12. Should be greater than 25 by 12. I hope that is okay. Okay, so in C part we need to find the set of values for k for which there are, or state the value, state like it's only need to tell what is the value of k for which there are 3 solutions in the interval 0 to 180, and we have just solved in the first part that this will only contain two results, two values in 0 to 180 degree. If you are putting k value as, see, if you are putting k value as minus 2, and any value, for any value we will be getting at most two values if we are taking the k as non-zero value. So what we will do, we will take k is equal to 0, so it just state the value, right? So we can simply put, let's k is equal to 0. If k is equal to 0, you will get one more root. How? Because then in that case it will be only this, and of course now you can get one more tan value, and that is going to be 0, and in that case, so we can see from here we will say that tan x is equal to 0, and tan x is 0 in 0 and 180 degree, so we will get two roots from here, and tan x is equal to 5 by 3, and you will get one root from here. So from here you will get two roots, from here you will get one root. So we require three solutions. So this is the only possibility when you will get two roots. Otherwise, if you are not taking the tan x is equal to 0, tan x will be in between 0 to 180, we will at most get one result from here, one result from here, one value here, one value here. This will be giving you the positive tan value, and this will give you the negative tan value. But we cannot get 3. So only possibility to get 3 roots if we are getting one root here, and one root in any of these two quadrants. I hope that is clear. So now from here you can write x is equal to tan inverse 0, that is going to be 0, and next angle will be 180 plus 0, that is 180 degree. So we got two results from here, and from this we will say x is equal to tan inverse of 5 by 3, and tan inverse of this is going to be 59.036 and so on. So we can write it as 59 degree only. So the three results are, solutions are 0, 59 degree and 180 degree. So I hope that is clear. So let's discuss the question number 12. Question number 12 says that the diameter of a circle C1 has endpoints -3, -5 and 7, 3. Find the equation of circle. We know what is the standard form of equation of circle if the radius and center are given. If the center of a circle is given as AB and radius is R, then equation of circle is x minus a whole square plus y minus b whole square is equal to r square. So all we need to find the radius and the center, and we know that diameter means diameter. If you find the midpoint of the diameter, it would be center. So center will be, for center it is going to be -3 plus 7, midpoint of these two endpoints it is going to be 7 minus 3, 4 by 2, it is 2 comma minus 2 by 2 minus 1. So now we have center, and the radius is, we can find in any ways, like by finding the distance between center and any endpoints, or we can find the distance, half of the distance of the diameter, length of the diameter. So let's find the distance by making like we can mark it as O, or center and this endpoint 7 comma 3 and 2 comma minus 1. So radius will be square root of the distance formula I am using, that is 7 minus 2 whole square plus 3 minus minus, that is plus 1 whole square, and it will become 5 square plus 4 square. 5 square is 25 plus 16, 25 plus 16 is 41. So it is going to be root 41. Now we have both. So the equation of circle will be x minus 2 whole square plus y minus minus plus 1 whole square is equal to root 41 square is 41. So this is the equation of circle C1. And let's discuss the B part of it. B part says that the circle C1 is translated by 8, 4 to give the circle C2. It is horizontal translation and this is the vertical translation. So we know that in the translation the size does not change. It means the radius will be same. So we only need to find the new center. So we can write new center, and new center is going to be translated. Earlier the center was 2 comma minus 1 from the A part. So we only need to translate 8, 4. Horizontal translation become 8 plus 2, 10, and vertical become 3. And radius is already given as root 41. So equation of circle will be x minus 10 whole square plus y minus 3 whole square is equal to r square, that is 41. Now we have the equation of circle C2 as well. So let's discuss the third. So C part is two circles intersect at point R and S. So let's see the diagram. See, we can see here they are intersecting at R and S, and we need to find we need to show that equation of RS is as given. So what is the RS? We can see from here, if we and they have these circles have the same radius. So if you are going to join these two radius centers, then this RS line will be perpendicular to both, and that is going to be perpendicular, and we can say that this RS will be perpendicular bisector, means these two are going to be equal, and hence this is perpendicular bisector of line joining these two centers. So we need to find the equation of perpendicular bisector of the line joining the centers. So first we'll find the midpoints of the center. So midpoint of center is going to be, and what was the center? Center was 2 comma minus 1 and 10 comma 3. So midpoint become 2 plus 10, 12 by 2, 6 comma minus 1 plus 3, 2 by 2, that is 1. So midpoint is 6 comma 2. So now if we have the midpoint and we need to find the gradient. Why? Because the equation of a line is given by y minus y1 times y minus y1 is equal to m times x minus x1. So we have this x1 y1, but we require the point, we require the gradient. So the gradient of line RS, it is going to be the reciprocal, negative reciprocal of the gradient of the line joining the center, and the gradient joining the 2 points, this is going to be 10 y2 minus y1 upon x2 minus x1, that is 3 minus minus 1, that is 3 plus 1 over 10 minus 2, that is 8, and it become 8 by 4, that is minus 2. So we have the equation of now we can find the equation of line RS. Now we can find the equation of line RS. It is going to be y minus y1 is equal to m times x minus x1, and here x1 y1 is given by 6 comma 1 and m is given by minus 2. So it is y minus y1 1 times minus 2 times x minus x1, that is 6. So we can simplify it and we'll show this is going to be the same. Minus 1 will go there, it is minus 2x minus minus plus 6 minus minus plus, so 2 6 are 12 and plus 1, or we have the same answer and it is proved or showed. I hope it is clear. So let's discuss the last part of it. It is hence show the x coordinate of R and S satisfy the equation this. Now since we have y is equal to this, so we can simply, now we have y is equal to minus 2x plus 13 as we have proved in the C part, and the equation x coordinate of R and S will be given by this, means we can put this y in any of the equation of C1 or C2, because this point will, this R and S are lie on both the circles, so we can put in any. I am putting in the first equation of circle C1, that was x minus 2 whole square plus y plus 1 whole square is equal to 41. We are going to replace y is by this, so it become x minus 2 whole square plus minus 2x plus 13 plus 1 whole square is equal to 41. So we can expand it. It is going to be x square plus 4 minus 4x plus, it is minus 2x plus 14, so minus 2x square plus 14 square minus 2 2 ja 4 into 13, sorry 14 4 ja 56x, sorry it is minus 56x is equal to 41. We can rewrite it and we will get x square here and 4x square here, so which will give you 5x square minus 4x and minus 56x will become minus 60x, and now it can be written as 4 plus 14 square is 196 and minus 41 from the other side, and so we got it as 5x square minus 60x, and this 200 minus 41 is 159 and it is plus, and hence proved. I hope it is clear. If you have doubt, you can ask me in the comment box. Thank you so much. In the comment box. Thank you so much.